This video is to go over introductory stoichiometry or gram stoichiometry, which is where we generally start with stoichiometry. The key thing here is that whenever you have grams of a substance, let's call the substance A, we can convert to moles of that substance using the molar mass as a conversion factor. So 1 mole of that substance will equal the molar mass of that substance in grams, all right? And then a lot of times we need to convert from moles of that substance to moles of a new substance. We'll call that substance substance B. And here there's always some mole-to-mole ratio that that is the same as the atomic level ratio. So whatever the atomic to atomic ratio is, that's the same as the mole-to-mole ratio. And then for moles, we normally go back to grams. And again, that's going to be using the molar mass, this time the molar mass of B. Okay, so let's do an example. So how many grams of iron are in 0.279 grams of Fe2O3? All right, so that's going to be our example. Now let's map out what we're given. We're given 2.79 grams of a substance, Fe2O3, so that's our first substance. The first thing we're going to do is change to moles using the molar mass. We're going to look for a mole-to-mole ratio at the atomic level ratio to go from moles of Fe2O3 to moles of iron, and then use the molar mass of iron to get back to grams. All right, so we're going to start with our 0.279 grams of Fe2O3. All right, and we're going to calculate the molar mass of Fe2O3. Is taking me longer than it should. That's 159.70 grams of Fe2O3 in every 1 mole of Fe2O3. All right, so now we've done the first step, grams to moles. Anytime you're stuck on a stoichiometry problem, the first step is always grams to moles, no matter what. All right, so now we're going to now do our mole-to-mole ratio. We want to get from moles of Fe2O3 to moles of iron, because that's the substance we're asked for. So now how do we do that? Well, the formula of the compound gives us the ratio, right? There's 2 irons in there's 2 iron atoms in a formula unit of Fe2O3. And so just in the same way that there's that atomic ratio of 2 to 1, for every 1 mole of Fe2O3, there's 2 moles of iron. All right. One thing to notice, I always work from the denominator going to the numerator. All right, and the reason for that is I know that the grams of Fe2O3 as the unit needs to disappear and move to the new unit. All right, so that's all. The step that we take is always getting rid of that unit and going to the new unit. So I always think of these denominators and numerator. All right, now going back to our map, we've gone from grams to moles. We've done our mole-to-mole ratio, and we're now in moles of iron. So now we need to do moles back to grams. And for every 1 mole of Fe, there are 55 point, and I'm going to get this number wrong. Oh, 55.85. Sorry, I don't have a periodic table handy, so I'm doing this from memory. So 55.85 grams of iron, all right? So now we're gonna multiply these through. Remember, when you're doing these, you multiply all of your numerators together and then divide by all of your denominators, all right? So when you punch that into your calculator, that's going to be 0.279 times 2 times 55.85 divided by the only numerator that's not 1 is the molar mass, 159.7. Okay, and that's going to give us, we need 3 significant digits here. Remember, that leading 0 is not significant. So we need 3 digits. So it's 0.195 grams of iron. All right. And then anytime we finish a stoichiometry question, we really need to ask, does that number make sense? So we were looking for a mass of iron within a sample of Fe2O3. So that mass of iron should be less than the original amount, which was 0.279, right? So that's good. And we also expect the iron would be the majority of the mass because each iron mole is almost 56 grams, whereas a mole of oxygen is only 16. So we'd expect the majority of the mass to be iron. So this answer, unless we made some silly small mistake, this answer makes sense in the ballpark of being correct. All right. So again, in these basic ones, we're going to change grams to moles using the molar mass. That find a ratio to get from moles of A to moles of B. In these ones involving a formula, they're usually going to be from the subscripts. If you were doing a reaction equation, that would come from the balanced reaction equation coefficients. I'll make a separate video about that. And then moles back to grams, again using the molar mass, but now of the new substance, which is iron. Right? Double check that your significant digits match of your starting amount and your final. And that's it.